Alright, let's go. So a bird leaves its nest at time t equals 0 for a short flight along a straight line. Now the bird then returns to its nest. So definitely pay attention to what's happening. It's a straight line. Bird goes from here, so at time 0, goes somewhere here, and eventually it comes back to its nest. So this is a straight line, something easy, yeah? Now the bird is modeled as a particle moving along in a straight line. The distance s meters of the bird from its nest at time t seconds is given by this. So what this is telling us that the general displacement, because remember s is displacement or distance, from its starting point. So depending on the time, it moves at a certain point and then it will return to its displacement. Okay. Now this is the part where everyone is literally a bit confused. Explain why we have a restriction. Well, so just like I said earlier, the variable s is the displacement from its initial point. So basically the distance the bird traveled from and for flight to come back to its initial point. Now what I just realized is that you could just simply factorize this equation, and you want to pretty much prove that when t is 0 and t is 10, you should get a 0 displacement, meaning it's returned. And because it's returned to its initial point, we should have no displacement. Now the reason why it's between 0 and 10 is because any t value between 0 and 10 will give you a positive displacement. Technically, if you put values like 11 or 12, you would get displacement too. But the thing is, we know it ends at 10 because once it returns to its nest, it doesn't move again. It stops. Because it says then returns to its nest, meaning by the time it stops moving at time 10, it's not going to move again. So that's why we're stuck at time 10. Now, you could just do algebra, factorize this, simplify this expression. I took out t squared and then factorize the inside and realize it's a quadratic with t minus 10 squared. And then you can just clearly say that, you know what, when the displacement is 0, basically when it's at its nest, this occurs at time 0 from basically its starting point, or time 10 when it returns. That's really it. And of course, like I said earlier, s is positive between these values because why? Mathematically speaking, every term is squared. So any value here will return a positive value, so it's positive. Yeah, so it's not bad. I mean, you just have to just be careful how you explain. You always relate to the context of the information, and of course, try and bring in as many mathematical proofs, and that helps a lot. All right, so let's look at B now. Let's find the distance of the bird from the nest when the bird first comes to instantaneous rest. Now, be very careful with this. When it says instantaneous rest, this means as soon as the speed hits 0, after it's moved. So we're not talking about the time it did not move in the very beginning, because then that would be no displacement. We're talking about as it traveled at some point in time, it eventually stopped to take probably a break. We want to find that distance from the initial point. Now, thankfully, because this is an equation, and one thing I love about this new mechanics is that if you differentiate this, you'll get the velocity. And then you can set that velocity to 0, just like your standard dy of dx equals 0. Well, I'll show you here. So what I did, let velocity equals ds over dt, differentiate this, and the cool thing is to differentiate it comfortably. Remember, 1 over 10 is a constant, so ignore that. You just differentiate the inside of the bracket. So t to the power 4 becomes, you drop the power 4, so you get 4t to the power 3. Drop the 20 down, you get drop the 3 down, and you get 20 times 3, which is 60. This becomes a 2. Drop the 2 down, you get 200t, and that's it. And now you say when speed is 0, i.e. when it's at rest, then this happens. Then all of this is set to 0. And you just solve for t. This is a cubic, but I mean, just have to factorize t out and then factorize a quadratic expression here into 2 other terms, and you're done. And then you realize that you have 3 solutions. Now, it's very important to understand what each solution means. The first solution, when t is 0, implies that you are at a starting point. So this is not the first time. This is probably when the bird began to move, just before it moved. Now, this is the first time at rest at time 5. So when time is 5, this is the first time the bird decided to chill, to probably hatch his eggs or get some food. This is what we want. And lastly, we got t equals 10. And this is when the bird returned to his nest. So of course, there's no displacement. So the only suitable answer is t equals 5. So when you plug in t equals 5 into the displacement equation, S equation, you can find out exactly how much he moved, or she. And the answer should be, well, I don't know if it's right, 6.25 meters. Plug it in and see what you guys get. I didn't check the solution for this one, but I think it was 6.25. Anyway, I hope this helps. And oh yeah, I put a note here as well. You don't have to put this, but this is clear. When t is 0, t is 10, you get no displacement. But yeah, I hope this helps, guys. And if you enjoyed this video, please give me a like, any feedback, and otherwise, stay tuned for the final question. Ciao.